All right, let's check on learning before my toddler destroys my house. So, again, this is for 16.3. We're doing um, trigonometric shifts and transformations and stuff and things. So, consider the functions f of x equals that and g of x equals that. So if you look at them carefully, they're the exact same function, except this one's a tangent function, this one's a cosine function. You know, they both have the plus 1, x minus pi over 2, amplitude of 2. Are the periods of these functions the same? Yes, right? No, they're not. So remember, and this is something you might want to write down because I had to look it up. Remember, the period for a sine and cosine are both 2 pi times the absolute value of b. So when we're looking at analytical, we could find, or at least when we're looking at the function, we could find b, which would be 4 in both of these situations. Or, I'm sorry, 1 over 4, because remember it's 1 over b. But the period for a sine and cosine function is 2 pi times the absolute value, whereas the period or the asymptotes for a tangent function would be pi over 2 times b. So there's a difference there, right? So no, the period of a tangent function is pi over 4 because b is pi over 4. So I don't think that's right. So no, the period of a tangent function is pi over 2 because b is pi over 2, and what did I just say? No, I think I'm going to go with this one. The tangent function is pi over 4 because b equals 1 over 4, and 1 over 4 times pi. I'm sorry, that's right. The full period, I was just talking about a half period when I spoke earlier. The full period is b times pi for a tangent. Period of a cosine function is pi over 2 because b equals 1/4, and 1/4 times 2 pi. That one I'm sure of because I was looking straight in the book. Let's check our answer. No, the period of the tangent function is pi over 4 because b is 1 over 4, and 1 over 4 times pi. Moving right along. When writing a function rule in the form of f of x equals generic function for the graph of a tangent function, how can you determine the values of h and k? So k is going to be our vertical shift up or down. And so we would figure that out by finding the midpoint. So like, if we had, come on, pen, right. So if we had something like this, we would find how that midpoint moves. So if you start reading these, you can look at the point at which the concavity changes. They're talking about that. So if you remember anything from concavity, concave is like the curl, I guess. So this is concave down, this is concave up, and it changes the midpoint. Anyway, you can look for the point of the concavity changes along the translated midline. The x-coordinate of this point is h, and the y-coordinate is k. Actually, that sounds pretty good. You can look at the point when the concavity changes along the translated midline. The y-coordinate of this is h. No, because remember, h is left and right, k is up and down. You can look at when concavity changes along the vertical asymptote. You're not going to have a line on a vertical asymptote. You can look for the point at which concavity changes along the vertical asymptote. I'm going to stick with that one. Let's check our work. You can look for the point at which concavity changes along the translated midline. The x-coordinate is the h, and the y-coordinate is the k. Yes, that's what we did. Oh wait, graph. You are given a cosine function, but not the function. Why could you state both a cosine function and a sine function for the graph? Explain. So remember, our sine and cosine functions look like that, and they're just kind of shifted of each other. So sine and cosine functions have the same periodic shape. I'll agree to that. Once a cosine function is written using the key features of the graph, a sine function can be written using a phase shift that is twice the period of the cosine function. So I agree with the phase shift. I'm thinking about if it's twice the period or not. I would say not twice the period. I would say, I think it's like a fourth or a half. One of those two. I'm going to say a half. I'm going with a half. I'm trying to visualize these things. If I wanted to find out the real answer and I didn't have them right here, I would either look at my calculator, I would graph a sine and a cosine and figure out how I would shift them, or I'd pull up a graph of sine and cosine. It's 1/4. I was wrong. So again, sine and cosine are just shifts of each other. Do the functions 3 cosine blah 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 and 3 cosine 2 blah 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 have the same graph? So okay, what's the difference? We've got a +4 here and a -4 there. Remember, that's our k value. So our f of x is, if you start with the parent function, is shifted up 4. Our g of x, if you start with the parent function, is shifted down 4. So do they have the same function? No, they do not. The graph of g is vertically stretched. False. No, they do not. The graph of g is shifted 8 units down from the graph of f. I'll agree to that. Graph of g is shifted 8 units down from the graph of f. Last but not least, here we go. A water wheel is rotated by moving by... Okay, got it. A water wheel is rotated by a moving water source. I swear I can reach. Suppose the motion of a point on the outer edge of one blade is modeled by the function that, where h is in height and feet measured from the water line, and t is in time, seconds, let t equal 0 when the time begins, when the, is at the bottom of the water wheel. Cool. So here's our graph. Which of the following graph correctly represents one cycle of the function with the midline graphed? So the midline is going to be in the middle, because it's called midline. So the amplitude above and below are going to be equal. So if you look at this first one, definitely not equal. Bottom has more. This one looks like the midline has the correct amount. Too low, too high. Yeah, we're going to go with that one. I'm not checking that one. So use the graph to describe what is happening in the context of the situation. Select correct values. So remember and I'm using this graph right there because it's there. The graphs are all the same, just the midline moves. Anyway, so the point starts. Where does it start? So it starts at, my scale is 2s, so it starts -2. So what does that mean? It means that it's 2 feet under water. It reaches the height of the center of the wheel in, so that's where the midpoint reaches. What is that? 3 seconds? It reaches a maximum height above the water line of, what's the maximum height? 16 to 18 feet. After how many seconds? That's 6 seconds. It returns to the height of the center of the feet after, okay, so we have to look at our midline. 9 seconds. It returns to its starting position after 12 seconds. That one wasn't bad. Surely some of our homework will be worse than this. But either way, we'll do it, and we'll do it in class. I'll see you there.